Hello and welcome to a new video. My name is Herwig Juster and today we continue with the third part of our plastic identification series. Okay, let us get started with a quick recap. In part 1 we discussed 3 simple methods of plastic identification, so mainly solubility, density and behavior on heat. And in the second part we discussed specific proof of selected plastics such as polyolefins, polyamides, polycarbonates and high heat plastics. And today in the third part we discuss the infrared spectroscopy for plastic identification. Okay, we have here 3 parts. So in general, what is infrared spectroscopy, what are infrared bands and some examples. So in general, you have to imagine we have here an infrared source which is sending infrared light on a sample. So in our case this can be a plastic film, a plastic part, most of the case a thin sample, and then one or all 3 things can happen. So the first thing, there can be an absorption. That means that the infrared light activates some molecules, which starts swinging. So there is energy transfer from light into movement, or there is a transmission of the infrared light onto the other side, where we see here the detector, or there can happen a reflection of the infrared light, so that the sample is reflecting it. And based on this transmission signal, we can identify the bands, and with that we can identify the plastic itself. So already mentioned, the lower transmittance means that there is an energy uptake, more energy conversion into movement of chemical groups, and the transmittance is then plotted against the wave number. And the advantages are, for example, you can think of the quality control of goods. You have the advantage to analyze in a few seconds the product what you have, in our case the plastic. And also when you have plastic recycling sorting facilities, there's also advantage to analyze quickly what is in your stream of products what you have here. Okay, so let's have a look at the infrared bands in detail. So you can imagine it looks like this. So we have here the different wavelengths and the different chemical compounds. So for example, alkenes and aromatics are in the range of 3000 Valve, and when you look at alkanes, they're activated at around 1600. So this already gives us some information about what is in this plastic compound. And to better understand that now, I brought here examples. I would like to start with polystyrene, amorphous plastic. And here you see now such an example. So we, on the x-axis, we have the wavelengths, the wave numbers, and on the y-axis the transmittance. And now what is really characteristic for polystyrene is the 3 bands, the 1450, 760 and 700. So this is when you analyze the sample, and this is nowadays automatically it starts searching different saved profiles, infrared profiles, and can match it then. But it's good to show here now that polystyrene has these 3 characteristic bands. And when we continue with another example, styrene acrylonitrile, here we have a similar band. So additionally to the 1450, 760 and 700 we have 2240. So those are the 4 you have to look when you see such a such a curve. And polycarbonate, also well known, amorphous engineering plastic. Here again the curve, and here we have several, so in total 5 bands which are characteristic for polycarbonate to look for. Another example is polyamide 66, also well known semi-crystalline engineering thermoplastic. It has 3 characteristic bands, so we have the 3300, 1640 and 1540. What you can look for when you have a sample in front of you. Okay, so here in the table I have listed some furthermore characteristic bands, so it's also you can find these bands also in the public literature, but here most common resins such as polypropylene and polyethylene. Also here high heat plastic PPS. Here you have to look for 6 of the characteristic bands. ABS, also well known, and polyurethanes. Okay, if you want to find more out about polymer engineering topics, I highly recommend you my blog findoutaboutplastics.com, as well as my online courses on the platform Thinkific dealing with polymer material selection. I will link also both the blog and the courses in the description below. Okay, thank you for watching, and do not forget to subscribe and smash the like button. Till next time, bye.